I'd like to do a little comparison here between two relatively inexpensive clamp meters. We have a Uni-T UT204A and the Mastech MS2108. This one is true RMS, this one is not. This one costs around $45, $46 shipped from different places. This one costs around $65. And we'll see which one is the better deal as far as construction and quality goes. So first thing is the Uni-T comes with a thermocouple. Well, I should tell you what functions it has. This one, beyond just doing volts and amps with the clamp meter, it also does temperature, frequency, diode test, continuity, capacitance, and this one has a relative button, which is good. Every multimeter should have that, and of course it has just the stupid hold button here that doesn't do anything except hold what you can see. The other multimeter, this one has true RMS. It does almost everything the same that this meter does, except it does not have temperature. And this one has backlight, this one does not have backlight. So there are a few differences between them. The overall feel of them, this feels like a typical Uni-T product. It's a relatively okay plasticky feel, nothing too special about it. It's the case is fairly rigid. It's built fairly well. The clamp has nice free action on it. Doesn't feel too cheap. The selector switch, easy to select, and with your thumb it's almost impossible to select in between. You really have to work at it. But it feels okay. It's a bit mushy feeling. It's not the best, but what do you expect for such a small wheel and an inexpensive meter that's supposed to do so many things? This one is CAT rated, CAT rating 300 volts, and CAT 2 600 volts, which is, I would probably assess that as being a fair rating for this meter. Up here, though, on the clamp meter, it says it's good for 600 CAT 2 volt and 400 amps. So it probably is safe for that. I would not disagree with that one. We'll see later on the inside. Now this one has it's a nice light feel. Like I said, feels good in the hand, not too bad. Comes with a cheap set of leads, of course. Probably some of the cheaper leads I've seen, but they're actually not too bad. There's no strain relief at the ends here, so the wire is eventually going to break. They say that they are Uni-T branded. It says this is CAT 2 600 volt 10 amp and CAT 1 1000 volts. So that's a little strange that doesn't even come close to meeting the ratings on the meter. The tips, they're pointy. They're not sharp, but they're pointy. It also comes with the usual cheap Uni-T thermocouple probe. Nothing different between this, the cheapest one, up to the highest end meters that Uni-T sells. Are all the same flimsy little piece of junk, but it's a thermocouple. You get it. On the other meter, you don't get anything. So it also comes with this nice case with a compartment for different things. You put your leads in here, your meter fits in here. It's softly padded on the inside, so it's a nice little case for the money, I think. You know, for the overall package, you're getting a fairly decent meter for the overall package. Let's take the leads out of the way and the case. We don't need to look at those right at the moment. The Mastech MS2108 is, well, it feels different in the hand, and I have to say the rubber at first glance makes it look like it's a much better meter. Has a bit grippier feel to it. It seems like it feels more solid, but one thing I noticed that I'm really not too happy with is that the case has some flex in it. You can see, maybe you can see it, I don't know. You can see when I squeeze on it here, that case is not being held together very well. There's not as much flex on the other side. Oh, actually, it's worse on the other side right now. I guess it depends on what the temperature is like around here. And the same thing up here around the jaw. You can see it's moving around there. The overall feel on the dial feels nicer, actually. I like the dial. It's very easy to get it stuck in between settings even with just your thumb. But one thing that really makes this look like a piece of junk when you're handling it is you go to off, but you can push this past off. Why didn't they put a hard stop in there? So both ends at the off settings, you can push it past the off. And the marker here is so hard to see that it's almost impossible to tell what you're selected, whether you're at the top or the bottom. If you just reach for this, you have to actually really look for it to see that little arrow. And of course this arrow is a raised one, whereas on the Uni-T, this is a little circle here. By the way, that little white circle there, I painted that in because, like I do on everything, if there's a little depressed area that I can put some paint in to make the indicator easier to see, I always do that. But this one doesn't have a depressed area. It's got the raised arrow on there, and I don't know how well you can see that on camera. Yeah, you can see it when I move it around. Anyway, so yes, this is it's an okay feeling thing, but you can see the dial moving around. It just feels really, really bad quality. And the jaws, they feel okay. They're well constructed. No binding, nothing moves around too well, or too badly, I should say. The buttons, they feel okay. They're just mushy feeling rubber buttons. The display, well, we'll compare the displays in a moment. But like I said, the thing that really bothered me is the way this case is flexible, really flexing around. This one here is rated for Cat 3 600 volt, which is a lot higher than the other one. So we will look inside, see if it warrants that kind of rating. On the jaws, it says Cat 3 max 600 amp. And what else can we look at here? Oh yes, this one also has a little light built into the end here, so that if you're working inside a panel and you're trying to get inside something to see things, this one lights up the area so you can see what you're looking at. The other one, this one has no backlight on it at all, so you're stuck with whatever lighting you have. So the backlight actually is nice. This little flashlight thing is okay, not a big deal. But I just wish the thing felt a lot better quality. The buttons on this one, of course, they're just typical Uni-T. Actually, these are little snappy buttons. I can feel that inside. These are not the usual, these are the tactile switches, not the rubber contacts inside. These are just the normal rubber contacts. Okay, so the leads that come with the Mastech, they are actually much nicer leads. They're very flexible. The wire is very nice. Does it have any rating on it? No, the wire doesn't have any rating, nor does the one on the Uni-T. The wires on those are just generic wiring. They come with these little caps that go on the end here, you can see. And with these caps on, you can still use them because the point sticks through a little hole in the end. So you can apparently change the cat rating to a little bit higher by keeping these things on. I really doubt. Well, maybe they do match it, but it says 1000 volt Cat 3. And that would only be with these tips on. 1000 volt cat ratings are usually with only a very small tip exposed. But if you push on this with enough pressure, the tip comes through the end and makes contact with whatever you're trying to contact. Oh yes, there is wire rating on here. These say 1000 volt 18 AWG. So not bad leads actually for the money. These are much better leads than what the Uni-T provides. Strain relief there too. So not bad leads. So the case that comes with this one, a little bit less impressive. Actually, it's a little bit better padded. Just enough room for everything inside. A little bit smaller, I guess. When you compare the size of the cases, you wonder why the Uni-T needs to be so big. This one's actually, actually I take that back. This one's a better case. It's got nicer padding inside it. But probably it needs it because I don't think this thing would take any kind of abuse at all. So let's open them up and see what they look like inside and compare the quality of them. So we'll turn this one off. Yes. So this one here, we take the battery compartment off here, take the screw out. And yes, I know my Canadian out gets people sometimes, the way I pronounce it. And the cover comes off here with one little screw. There's a little clip here that holds one side in, and then the other side is held in with a screw into a metal insert, which is good. This meter has one benefit. It uses AAA batteries. AAAs are a little bit more expensive than AA's, but I think they're better than using 9-volt batteries. So let's open this up here. And you'll see that there are only 2 screws so far spaced apart here. It's no wonder that the case flexes in the middle, because there is so much pressure on some springs inside and other things to hold shields, and for the battery contacts here to make contact. I think that's just a really, really bad design. The case has a little bit of overlap. It's not double grooved, only single groove, so not very much blast protection, but if you're only measuring voltage, I guess you really don't need it. You can see inside here the jacks. They're okay. They're the split tube type, soldered on one side. We have what appears to be a PTC here. Not too sure. Yeah, it looks like a PTC. And we have some resistors, and that's all there is inside for the input protection. Probably good enough. I could test this later on. I might do that with a high voltage test like I've destroyed another meter with. You can see the clamp meter, this flat ribbon flex cable going up to the Hall effect sensor, which is built into the jaws here. And you can see it gets pretty crinkly and bent up here trying to pass through this section, so that might not be that reliable. We have a lot of little tiny cheap trim pots all over the place for adjusting the accuracy on this thing. Number of chips on here. One of these is going to be the true RMS converter chip, and you will see here that I've had to put some wires in here because this thing was so cheaply built and so poorly hand soldered. One second, where did that cable go? I just had the cable in my hand here to show you well, it had another piece of ribbon cable in here, like this type, soldered to these 2 points going over to the flashlight LED, but it was so poorly done that I opened it up twice. I think I may have pushed on the cable like this twice, and then the flashlight didn't work anymore, and I had to replace that wire or that flat flex ribbon cable with these 2 wires just so I could make that work. So I would believe that maybe even just a couple of bumps, dropped this a couple of times, that flat flex cable would have bounced enough, flexed the bit, and fractured the solder joints even without taking it apart. So I just found it. It fell down on the floor while I was moving things around. Here's the cable that was originally there. And you can see the amount of solder that they put on different things. It's just a terrible piece of junk inside. The whole circuit board is only held in by clips, just held into the case by these little plastic clips that you can see on the side. These 3 screws here hold in the LCD assembly. And when I first was taking it apart, I thought, okay, I'll take apart the screws here, and one of them was actually stripped, and I can't remember which one it is, but one of these screws is stripped. I'm not going to take it out again because all that does is strip it again more each time. So we spread the case apart, push on it, and the circuit board comes out eventually. It pops out almost on its own from the pressure. This thing has a lot of pressure holding everything in place, and even the sockets come loose here. You can see the sockets here are moving. So you know, it's not worth me taking it apart because it takes sometimes half an hour to get this thing to stay back into place and have these clips pop on. But trust me, the insides are the other side's really cheaply made. The traces for the selector, they're very rough. It looks almost like fiberglass was not completely well made. So you have this waffle kind of area underneath the contacts for the selector switch. It's everything I touch on this just makes me think, wow, they could have spent a little bit more time worrying about quality. And if I take this apart, literally, it will take me 20 minutes to get that board back inside. So I really don't feel like taking that out. But trust me, the other side, it looks pretty bad as far as quality goes. You see solder, a little bit of solder splash in a couple of places. I'm not going to get in there, but trust me, I'm really not impressed with the quality of the construction of this thing. So, but how does it compare to the Uni-T? Well, the Uni-T UT204A, like I said, it's not true RMS. It does not have a backlight, but it does measure some other things the other one doesn't. So I think this one's actually a better buy than the Mastech. So let's take the battery compartment or compartment screw out. Okay, of course that one is just a self-tapper into plastic. That's the one thing that really is a letdown on this meter. You would think that they could have put at least one metal insert in there so that we wouldn't be stuck with a strip screw after replacing your batteries all the time. 9-volt battery, of course, Uni-T branded battery, but again, no snap clip. It goes directly onto some contacts inside. That's not bad, but it's only this screw and that screw that hold this together again. So not the best construction, but this one seems to hold itself together a little bit better. There's not much flexing in the case, and it takes a second to get this apart because it's snapped in. There are some snaps on the sides here. No, we'll just force it. Come on. Nope, it's not going to go. There we go. Takes a bit of work to get it apart, and the lanyard fell. This one is a dual circuit board construction. Chip on board here instead of an actual chip like the Mastech had. The soldering is a little bit less quality, believe it or not, than the Mastech. We have a lot of trim pots again here for adjusting things, and overall I would say they're basically built the same way inside on the circuit boards. The mechanism here for the jaw to me seems to be basically the same mechanically. Let's have a look at both of them together here. So there's really not much to recommend between either of them. This one has a better screw holding the one jaw in, and the way the cable passes through is nicer on the Uni-T. This one, little tiny screw. That's you know what? I guess I would have to say the construction quality goes to the Uni-T on the jaw. And the input jacks down here, you can see one's directly to the circuit board, the other one goes through PTC. Not much else protecting the input. The case itself, again, there's just a little bit of overlap, not much blast protection. Generally people are using clamp meters or using them in distribution panels and other things to look at power distribution. So when you're using the clamp meter, you don't really have much issue with power getting into the bottom here. But if you are in distribution panels and you start playing around with power and something goes wrong, that's really not a lot of input protection, especially when you have passages where the blast can come straight out and into your hand. So not the best protected meter, but for $45 for I guess a highly featured little cheap clamp meter, it's what you would expect. Now that I have them both back together, I forgot to mention one thing about the Mastech. Let's get the leads here. We just need one. You will see here on the common jack, when I push in the lead into it, you can see the whole thing bounces in and out. We're flexing the whole circuit board or something inside, and it just feels so cheap. I'm sure that's going to fracture something eventually. It just feels really bad. The input jack, I think, is a little bit better, if I remember correctly. Yes, that still feels very wobbly and cheap. It just doesn't give me any feeling of confidence that this thing is going to last. The cable broke inside just opening it up. The screws are stripped, holding the LCD assembly inside. The range switch. Anyways, I just wanted to add that on here. Maybe I'm feeling a little prejudiced against this thing. I thought it would be much better than the Uni-T because of the price, but it's usable. But don't think of using this in an industrial setting. This is going to break eventually. It's just going to let you down. So let's have a look at how these things measure, how well they work. And let me get the leads for the Uni-T. I'm not going to do any real extensive tests on this, but you will see that there are some problems that are worth investigating later, maybe with the Mastech, because it really doesn't do a very good job on on its current ranges, which is one of its what its reason to be. Don't have the same problem with the input jacks being flimsy or feeling bad on the Uni-T. They feel pretty good, but you can see that the leads are just really cheap. There's just junk leads, really. Okay, so let's put this on volts. Let's get my voltage standards reference here, DMM check. And this is reading on DC by default. That's what this one defaults to. And we put it on here. And yeah, that's within spec. No problem there. Let's try the, oh, there it is. Yeah, I have to look very carefully. What setting is it on? This one defaults to AC when you put it on volt setting, which is what you would expect for a more industrial type meter. And take the tip covers off. And let's measure the voltage here. And like I said, yeah, I just told you it's on AC and I left it on AC. So let's put it on DC. I think you can see there's a difference in the displays too. Another difference between them is that there's more information on this display. I really don't like the display. It's kind of hard to see. Things are buried into the corner. Uni-Ts always have nice displays. Almost doesn't matter what model you buy from them. Every display they have looks pretty good. So anyways, yeah, this one's within spec, no problem there. But when we select these on amps for measuring current, okay, the Uni-T defaults to DC. So it defaults to DC. You have to manually select here, but this one has separate selections for DC and AC. And you can see that there's a little bit of a problem here. Yeah, I can understand this picking up some noise and being a little bit out on its DC range here. We can rel that out. But you see here, this is way, way out, and it's fluctuating all over the place. I don't know what's going on inside this. Maybe taking it apart a couple of times has flexed the circuit board, and one of the trim pots has gotten out of adjustment. I don't know. Let's select AC on this one. And you would expect this to be very low, not have any offset. Eventually it should settle to almost zero. This one's offset a tiny bit, but yeah, so big deal. Oops, meant to hit rel that out. You rel that out, it stays at zero. Let's put this one on AC. Problem is you cannot, which button is it again? It's very, very easy to see, isn't it? I believe it's this button. Oh, these are the range, of course, RAN range. No, there is no rel button on here for the AC setting. So you're stuck with whatever offset it thinks it has. So back to amps, and the offset just keeps climbing and changing. And if you go back to DC, you'll have your huge offset that has to, I'm sure there's a trim pot in there that I can fix that with, but it shouldn't be like that out of the box. Put it back to AC, and sometimes you'll see that it's up to like 1.9 amps, and then it slowly climbs down. If you hit hold and then released hold, this one has just been all over the place. Right now it's reading relatively good, but before it was just crazy. It was all over the place. Maybe me taking it apart again and putting it back together has changed something else on the circuit board, but this is not going to do anything for you in the field that you can rely on. It just doesn't work. If I remember correctly, if I push this, oh, that's Hertz, yes, of course. And of course, nothing here is intuitive. You have to play around, but there is no way to rel out DC. So that is one of the problems with this. There we go. You can zero out DC, but it starts climbing all over the place. Like I said, nothing is very easy to use on this. Everything just feels wrong. I guess I'm a little unfamiliar with it, so my prejudice is showing. But if you select this one doesn't give you rel. You cannot, that's right, you cannot rel the the AC setting, when you hit select, this gives you the inrush, the peak current thing, which is another thing this one doesn't have. I haven't really tested this. I don't have a way to test inrush accuracy, but and if you hold it, oh, there we go. Now you see it's way up there on amps. There was nothing going on. I had nothing in the jaws. So all I can say is if you want to buy a cheap clamp meter and you need to choose between the two, unless you absolutely need true RMS, I would not buy the Mastech. Every Mastech I've played with, everything I've looked at, they always feel cheap in some way, and this one didn't let me down. The leads are really nice on it. I should say it didn't let me down in my prejudice against it. It just feels cheap in every way I could see. If you want a cheap clamp meter and you're not worried about true RMS, then I have to say the Uni-T UT204A is probably the better buy. Of course, if you are just playing around and you don't need industrial strength and industrial durability, then yes, the Uni-T. But if you're really working inside of power panels and you need to have something that you can rely on not to explode in your hands, those kinds of things, you need to buy something more like a Fluke or some other higher brand name, something you can count on for its safety inside of power distribution. I guess I should also point out some of the other accuracies that these two might have. So let's check out. This one's set to ohms right now, so we'll check out the resistance measurement. This should read 999.7. Yeah, that's within spec. It should read 9,999. Again, with its spec. This one should read 99,990. That's close enough. What is continuity like on this one? Diode measurement, I'm not going to bother. Continuity. Instant, not latched, but instant. And with these cheap leads, yeah, you get the scratchiness, but instant. Okay, that's not bad. This will, of course, also measure frequency and degree C on the temperature probe. Let's plug in the probe just so that you can see that it does work. And I believe, yeah, the temperature in my house right now is up there. Don't forget I'm living in the middle of the desert in Chile here, so temperature gets quite high in the daytime. And let's check the Mastech. Yeah, I always have to look, where is it pointing? Because you can't see where this stupid dial is pointing. It's never easy to see. So here we go. Let's check the resistance measurement. It should read 999.7. It's a little low, but close enough. 9,999. Low again. 99,990. Low again, but probably within its spec. Let's check the continuity. Actually, that's very nice. It appears to be even latched and instantaneous. That's probably one of the nicest continuity testers I've seen on any cheap multimeter. As far as capacitance goes, they both measure capacitance, but this does not go any lower than microfarads. So this is not for measuring anything other than just power capacitors, those kinds of things on industrial equipment. Now let's grab a couple of capacitors and just show you what I'm talking about here. So let's get out this one here is a 2.2 microfarad. And yes, I know I'm not measuring it the right way, but come on. And that measures fairly quickly. Let's get a 0.047 microfarad here. And you can see that it's way out on the measurement, and it doesn't range down. So you're only reading microfarads on here. This is no good for reading electronics. Okay, so let's measure the capacitance with the Uni-T UT204. We'll put it on, we will zero out the leads and everything, put it on the 0.047 microfarad capacitor here. 50 nanofarad, that's pretty close for what it should be. Let's test out the 2.2 microfarad. This is a 10% tolerance one, so it gets there fairly quickly, reads it correctly. Let's try something a little lower on the range here. I believe I have a 6.8 nanofarad capacitor handy here. And yes, that reads pretty close to what my Bryman and my other meters read. So this actually has a lot more functionality, better built. I like this more than the Mastech for the accuracy of it, for electronics too.